Welcome to the project presentation for DAMG 6210. T1, are you ready to go?
Yes, Professor.
Great. Go ahead, please.
Sure. Hello, everyone. This is Team 1, and the project that we implemented is Reality Management System. So the main overview of the project, in the next slide. The main overview of the project is simply to create a tool that would help the landlords, owners, and in order to manage properties or rental properties, to be more precise, and giving them a centralized solution by considering different KPIs such as tenant details, rental payments, maintenance, request, etc. There are other key entities as well, which help us giving an unified platform where they can use these to manage their rental properties. So in the next slide, we have shown our ERD diagram. So basically, this ERD diagram will give you a gist of how the data model is designed and the way the data is stored in our database. You can see some key entities like apartment, lease, customer preferences, maintenance request, and some other key features as well, which will help the landlord or the owners of a property to analyze and to manage their apartment in a better way. So we have considered a very broad spectrum as well, like different things that we consider while taking up an apartment, which people consider while taking up an apartment. So all these things like the rental price, the average pricing, and all those things that comes into picture, we have considered in this ER diagram. In the next slide, if you can see, so basically in terms of our project description, the database that we have created has achieved the following objectives. Number one is to maintain the data by using enter, update, and delete operations. Performing searches, basically this is something like to searching the apartment, the different types of units, the available units that are there, the leasing things, and all those leasing dates available, and different kinds of factors as well. Then to track the status, whether the monthly, it can be the monthly rent payment, what kind of maintenance requests are coming in, when is the lease period, how many times are left from the lease period, and finally reporting all these stuffs. So basically, this is the gist of the project description. Now, Makrand will explain the coming slide. That is the technical approach.
Yeah, hi, this is Makran. So these are the table level check constraints and computed columns we have implemented in our project. Can you show the so like we have implemented a function to concatenate the first name and last name so that the full name is easily available for further use. We have included a get rent amount function which calculates the rent amount for a unit and keeps a track of that. We have created a function to check if the rent amount is greater than 0, as well as we have created a function to calculate the lease period in which we are checking if this end date is great after the start date. So these are the some of the check constraints we have implemented to check if the payments from the tenants are having amount greater than or equal to the rent amount, to make sure the data being entered into the tables is meaningful and valid. Also, like we are using the another computed column calculate lease days, which again calculates if there are valid lease dates for the specific unit within the database.
So next we have implemented some views in this project as well. So these are the list of views that we have implemented. One is view available units. So basically in this view, we'll be having all the details about those apartments units that are available to be rented. So this is one view. And in another view, it's about, finding the rent range. What's the maximum range, maximum rent and minimum rent for a given unit, so that later on we can use them, for visualization purposes to understand how, each unit, how the rent of each unit type has been varying. And then the next is unit availability per year. This is just to understand how the rent is varying over time, like each year, what's the difference between their average rents. And the tenant leases, this is a, a wholesome report to have details about the tenants, like their personal details, their contact details, and the apartment unit they have occupied, and also the lease period, I mean the duration for which they're staying in that unit, and everything else. So these are the views, and some of these views we have used for creating visualizations. In the next slides we'll be coming up with them.
So this is Mani Deepak. So now I'll explain about the visualizations and what insights we can gain from these visualizations. So we have created views to report and also visualize the data. So this is the first graph is the minimum and maximum rents. We have used Tableau to do that, and that is for different type of units. And the second graph is a combination graph of a bar and a line, where you'll get the average rent of units available in different years, and also the number of units for in each year. And now maybe Siddhi will explain the other two graphs.
So we have also created a bar graph wherein the most rented apartments or rented units, the types of unit which are being rented more, and we have considered the data which is related to the Boston and the cities which are nearby the near the Boston. And can you show the pie chart?
Guys, sorry to interrupt, but it's more time is up.
Okay, fine. Yeah, so that was our what about our project was. So if team 20 has any questions about this, they're open to ask.
So one question I had was, what is the purpose of the customer preferences table that you had in the ERD?
So the customer table is like, we need to know what are the preferences of the customer. Also, we can get the like we can understand their minimum and maximum rent expectations. For that, we have used a customer preference table. Like just yeah, we can also, and we have also included a feedback table for the tenants.
Okay.
So like customer can also view their feedbacks, and depending on that they can prefer which units or which apartment or in which city they want to take the apartment and unit in.
Okay.
So that was the understanding we had.
Very.
Any other question for team one? Okay, great work and the presentation from team one, and thank you for the question. Let's welcome team two.
Hello, Professor. Like, should I start my screen
Yeah,
share?
yes.
Okay.
Team one, please stop sharing your screen, and then team two, please go ahead.
Yeah, so hello everyone. Today we are excited to present our car rental database management system. The primary object of the system is to provide a dependable and efficient way of managing car rental business by offering a large number of selection of cars, recording customer services and car maintenance, and utilizing technology to make the car rental system simple and hassle-free as possible. So the business problems we have addressed in this database management system are like, customers can rent a car by selecting the car depending upon their preferences, like time, location, and category of the cars. Customers can opt for the preferred insurance and discount types available. Customers can also get billed according to their usage. They can keep a track of payment details, including payment information, status, and transaction details. Customer service supports are also provided. Customer can raise a complaint if they want to provide their feedback on the car rental experience. Maintenance can be tracked to manage the services and repair history of the rental car. Over to Pawan.
Yeah, hello. Next, I'll be talking about the entities and the entity relationship diagram. We have a total of 17 entities as shown in the slides, and I'll be explaining about how these entities are related to each other. Coming to the ERD for the car rental management system is as follows. The person table is the parent table, and the customers and employees tables inherit from it and has a one-to-one relationship. And car reservation table has many relationship with multiple tables because this is the main table. It has one-to-one relationship with the discount table, as each car reservation may or may not have a discount. It has a relationship with the insurance table, as each car reservation will have an insurance. And it also has a relationship with the billing table, as each car reservation will generate a bill. And finally, it also has a relationship with cancel reservation, wherein we have a dedicated table to accommodate all the cancelled reservations. Billing has a relationship with both payment and penalty tables, as each bill may have 0 or more payments and penalties. And the payment table is used to track all the payments which are made for a particular bill by the customers. And finally, we have the billing penalty table, which is a dependent table which manages the penalties associated with the bill. Over to Shreyanshi.
Yes. So, so I'll be explaining database schema creation. So we have created tables and file levels considering referential integrity constraints. So each table has its own set of columns, which defines the table. Here, the check constraint is on, here we have a check constraint on person table, which checks whether a given person meets the minimum age requirement for driving, which is 18 years. And the function for checking the age requirement is given in the following slides. Speaking about the views, this views gives us count of customer support requests. It gives us car rental statistics. It also gives us consolidated details related to car categories and car reservation, which is later used to create visualization reports. Over to Dhruv.
Hello everyone, sorry I was on mute. I'll now explain the triggers and functions we have used. I'm Dhruv, and the triggers which we have used are car check car availability, because this trigger is important because we didn't wanted to reassign a car to two car reservations at the same time. And we also checking the check drop off time, because we don't want a drop off time to be greater than so lesser than the pickup time, because it is not possible. Next slide please. Here insert billing and update billing are basically used to generate bills and total amount that the customer will be paying, and according to that we will be taking the payments from the customers. And next slide please. Here are the functions on which we are calculating cost and drop off time, and also calculate penalty amount. So I'll explain the calculate cost, because it has all the cost which we are calculating for a user, and we have fixed costs, insurance, discount, everything is calculated using the tbu.calculate cost function, and we have formulas for that. And for the calculate penalty amount, we are taking penalties only if the customer hits any penalty. If they are giving car late or submitting it late, then we will calculate the penalties accordingly. Yeah, next slide.
Guys, sorry to interrupt, the time is up.
Okay.
Let's just try to finish it up. Okay, go ahead.
Yeah, Daksh will continue with the visualization.
Yeah, so basically visualization is helping us to get the insight from the business. Here we can see like customers are more likely to continue with the reservation if they are reserving a luxurious cars. Next. The map basically shows the reservation by city. Next. The bar graph represents that customers are more likely to select comprehensive insurance. Next. So this is the basically a penalty distribution pie chart. Next. Yeah, so like our project provides a comprehensive solution for managing car rental services. Thank you.
Yes.
Does anyone have any question regarding our project?
So about the visualization, the insurance visualizations which you have created. So like what insights can we get from that, like that particular visualization?
Yeah, so basically we have provided a table of insurance which has a number of insurance which the customers can opt for. Like basically when you rent any car, so we are provided with options wherein we can choose a comprehensive insurance or a various amount of options depending upon the cost and the coverage of the insurance. So here this data depicts what are the most popular insurance chosen by the customers. Like, is it comprehensive or is it bumper to bumper insurance? So this gives data to the insurance companies and the car rental management system so that they can provide the various combinations of services with respect to insurance, which would be useful for the customers, and it affects the profits as well. So that was the main intention behind it.
Okay, so this data would be useful to the insurance companies as well.
Yeah, both insurance and car management system. Yes.
Okay, I got it. Thank you.
Yeah, thank you.
Great work from team 2, and I like your visualizations, and thank you for the question.
Yeah.
Let's welcome team 3.
Alrighty, can you guys see my screen?
Sure, yeah, you are on.
Alrighty.
Okay, so we're group 3 presenting, and our project is on a movie management database. So first we're going to go over the database purpose. We chose to design a database that can be used by streaming services to make it easier for subscribers to find new movies to watch. It will update and maintain film information, including awards, cast people, and production information for all movies. It can also store and update information about film availability for streaming based on the various services users may have, which can then be selected as a filter. The purpose, it's to provide a service to users to match them with potential films based on their preferences. They will be able to sort or filter movies based on selected criteria recorded in the database, which will then provide the recommendations. And currently there are no cross-platform databases, so this is a new service that connects the offerings from multiple platforms to match these with individual preferences. So it's just creating a new service.
So to rehash, the problem we were aiming to solve with this database was mostly centered around allowing users to view movie availability across all streaming services. This would allow them to see if a movie is easily available to them or not. But it could also be useful to users for deciding which streaming services to purchase. By setting filters on an all-encompassing movie database, it could be easily visualized which services provide the most individualized value per user. In addition to being useful to users, the database could also provide increased insight to streaming service companies themselves. Services can now easily analyze movie availability on other platforms and use it to make informed decisions on additions to their own availability. Lastly, it would be a one-stop resource for movie information that is certified up to date with the most recent updates collected from appropriate sources. And as you can see under business rules, information that will be available includes genre, production company and crew, cast members, location, awards for movies and individuals, and streaming platform specific language availability as well.
So the EI diagram is designed in crow's-foot notation. This EID follows certain design requirements. Firstly, primary keys are specified by PK next to the field in each entity. This helps to identify unique record in the entity. Secondly, any foreign key fields are represented by FK within the entity. Thirdly, lines are drawn to represent relationship between entities and fields. These lines help to establish the type of relationship between entities, whether it's one-to-one, one-to-many, or many-to-many relationship. Lastly, during the normalization process, all many-to-many relationships are removed. This helps to eliminate redundancy and improve the performance of the database. This ERD diagram that we implemented using the design requirements. For this presentation, I'm considering the example of movie platform and movie platform. So here movie entity stores important information about the movie, such as title, description, rating, duration, revenue, etc. This entity is directly related to almost all the entities in the database, and the primary key is movie ID. The platform entity captures information about the different platforms on which movies are available, such as streaming services or physical media, including the entity in the database designed to track the availability of movies across different platforms, and is directly related to the movie entity through any associative entity due to many-to-many relationship. The movie platform entity is associative entity between movie and platform, which prevents many-to-many relationship. That's all about design requirements. Over to Hanman.
Hi, I will talk about how we use SQL DDL to implement our movie database. We use Create to create the movie database and tables and views. I will show you some example of views in the next 2 slides. And also we use Alter to add a table level constraint to check the validity of insert data. And these 3 images shows the creation of the movie table and check the validity of the inserted release here and the movie ratings. And next. And for the view implementation, the first one we implement is top gross movie views, and here are the 10 movie results, and it is sorted by the box office revenue. Next. For top 3 movie views, notice here it has 4 results because it is sorted by the rating, and there are 4 movies with the highest rating with 9.
Alrighty, and now we can finalize with our database visualizations. So we'll obviously use these visualizations for business insights. Going on to the next slide here, we have our first chart, which is our box office revenues based off of movies. So you can see it's just a sample of movies that we have in our database. Obviously, the more movies we would have, the more data we would get. The next is the ratings. Like Henwin said, we have, if we did our top 3, we would have the top 3 movies here as the highest rating, but you can see the other ones within the database as well. Next,
Sorry
we
to
have.
interrupt. Sorry to interrupt. Your time is up.
Alrighty. So as you can see, we just have a couple more visuals. One is location, other one is platform name with the count for each movie within the platform, and then just additional visualizations here. Questions?
Yeah. How are the movie ratings calculated when it is being stored in the database?
The rating system could vary based on the platform, but typically ratings are calculated as an average of user rating or rating from critics.
Okay, yeah, thank you.
Any other question for team 3? Okay, great work and the presentation from team 3. Great visualization and the reporting. And we have a large class, so it's kind of important we follow the schedule. Thank you for your understanding and the patience. Let's welcome team 4.
Hello, everyone. Good morning. We are from Team 4 and I'm Kritika. So we have chosen podcast streaming application database as a topic for the project. So coming to the description of the project. Yeah. The podcast streaming database is created in such a way that it stores the information about podcasts as well as user preferences. The users can search, listen, download, and rate, and create their own personal playlist. So the functionalities such as searching the database and rating the podcast, as well as creating their own playlist along with the favorites, is what the database is designed for. Also, it is designed in such a way that there is an efficient user experience as well as the data storage is very secure. Coming to the next slide of objectives. The objective of the project is to process the information related to podcasts, which include the speakers, ratings, genres, collections, as well as subtitles. And the next objective is to manage the user information and the preferences, such as playlists, favorites, and downloads. Then we have the objective of creating the database, which is user friendly and is easy to search and browse for podcasts. Also, we have the objective of that the database should be very secure and it should have protect the user data which is used in the login credentials. Now coming to the business rules of the project. So the podcast app offers the comprehensive listening experience for all the users who are looking to discover the podcast. The first one is the playlist. The user can create their own personalized playlists. Next is the favorites. The user can add one or many favorites, and which they can mark with a heart, and it will get added to the favorite list. Then is the download, so that the users can access the content offline. The user can download the podcast. Then comes the podcast management. With the ability to download, add the playlist, and add to favorite lists, it is creating an easy to use interface. The last one is to create a user registration and login, where the users must first register and then log in to access the podcast database. Now we'll go forward with the design, and Pramod will continue.
Yeah, we have 15 entities, that is users, playlists, downloads, favorites, podcasts, podcast playlists, subtitles, genre, and collection genre, collection, speaker genre, podcast collection, speaker collection, speakers, and ratings. And just a minute. Yeah, and this is our ERD. And some highlighting relations are users and users to playlist, that is it has one-to-many relationship, and users can have 0 or many favorites, and users can have 0 or many downloads. And next is like podcast to podcast playlist, like it has like one-to-many relationship, and these are some of the highlighting relationships. So next, over to Shavya.
Can I go to the next slide? Yeah, so this is how we created our database using create statements. We have added check constraint for email so that it would contain @ and ends with .com. We also added a constraint for rating and release date of the podcast so that it doesn't have a date which is after the present date. Can you go to the next slide? So these are our creation queries for the rest of the tables. Next. So SQL encryption, we encrypted our password field using a password and AES encryption. These are our insertion statements for the user table. We have encrypted the password field for each entry. Now Sweta will continue.
Hello, next slide. So we've implemented a few views. One of the view is where we can find out all the favorites of a user with the first name and last name. Next one, next slide. And this is for checking all the downloads of a user. And this is the example view. Next. Yeah, so these are this is like an overall view for all the speakers and their podcast and which collection the podcast belongs to. And we joined 4 tables for this. And this is the output for select all from that view. Next. So we've implemented some functions as well. In this, you can find the number of users, the number of favorites for each user by giving the input parameter as user ID. The next function. This is getting the number of downloads for giving the user ID as input. Yeah, so the visualization, whether this is going to talk about.
Good afternoon, everyone. So this column chart displays number of podcasts in a database per speaker. It is clear that some speakers have produced more podcasts than others, with speaker number 2 and 8 having the highest number of podcasts, while speaker 4 and 6 have the lowest. This chart provides a snapshot of all of the podcasting landscape, and we can be used to identify trends and patterns in the data. Next. This pie chart displays the number of podcasts in each genre present in our database. So there's a total of 11 podcast genres in our database. And as you can see, according to the database, crime genre has the highest number of podcasts compared to
that's time.
Just one slide. Next. So yeah, this is just a bar chart showing number of podcasts downloaded by each user, and you can see that. So for example, if you see the pop-up, person named Pramod has had 4 downloads. It's shown there, and yeah, that's it.
Yeah.
Any questions?
Why are there different types of users?
Yeah, so we've there's like a premium user and a normal user. So for a premium user in the real life application, there won't be any ads. Like if this database is for real life application, and also we've limited the number of downloads for the premium for the normal user. Premium user can download any number of podcasts. That's all.
Great work from Team 4. Thank you, Team 4, and thank you for the question. Let's welcome Team 5.
Good morning, everyone. We are Group 5, and the project that we chose is Pharmacy Management System. The main purpose of our project is to automate the workflow and improve the efficiency of a pharmacy. As we all know how important and vital role healthcare plays, and dispensing the medication to patients, not only giving the right ones at the right time, is also equally important. So our project focuses on careful verification process that demands significant attention and time during their workday. Through this project, we want the pharmaceutical companies to gain a holistic understanding of their operations and monitor the production and also increase the flexibility. Now let's see the business problems that we have in our project. These are the problems that we have addressed in our project, and they focus on how to increase the efficiency, optimize the stock, and also manage the quality of a pharmacy. Now, my teammate Mayuri will continue with the business rules.
So we have established a set of business rules for our project. For example, each client and company will have their own unique address and contact information. Each employee can be employed within one company, and canceling, rescheduling, or transferring of operations won't be allowed. Batch is only updated after the product has necessarily passed through all the production stages like the quality check and the tests. And also stock will also be updated only after batch has been approved for testing. And we have used single raw material and single packaging material for the production process. Material ID is referenced as raw material ID and packaging material ID. And batch ID for raw material and packaging material will already be obtained from the vendor. Next slide. Oh, next slide. Yeah, so this is the entity relationship diagram. So one of the important entities over here is billing, as it is related to other entities, and it contains important information such as billing ID, order ID, client ID, company ID, and salesperson ID, as well as batch ID. Next. So these are the list of 15 entities, such as company, contact, address, client, employee, and so on. Next slide. So for the table creation, we have created the 15 tables based on the entities in our database, which is named as Project Group 5. So we have used the create table query to create all these tables. Prisha will be continuing next.
So for insertion of data into a database, we have used two methods. First is the data import wizard, using which we have inserted data to 3 of our tables. Next, we have used the SQL queries, insert queries, to insert data into the rest of our tables. Next, we have added a data encryption trigger. So whenever a new row is inserted or updated in the employee table, the update SSN trigger encrypts the SSN for security purposes. We have added 3 constraints: check age, check result, and check quality. Check age to check if the employee is retiring and if his age is greater than 70. Check result and check quality are for testing the product so that if it fails at any stage, it doesn't go forward. Next, we have 4 computed columns. Date of birth column is being used to calculate the age. And in the billing, we are using unit price and batch quantity columns to calculate the subtotal amount, tax amount, and the total billing amount.
So here we have implemented 5 views. The first view demonstrates the monthly sales per year, and the view 2 depicts the ranking of the client based on the total sales. So this helps the company to see who is which client is more profitable to the company. And in view 3, we are demonstrating the ranking of the products based on total production. And view 4 helps us to see the overall company address, the company details, which contains the contact details as well. And in view 5, we are showing the overall view of the billing details, which will help to see the whole view of the client and his contact details and the order details, which will help the company to track what is going well and if the order has been delivered to the company. And moving on to the data visualization, Divya will talk.
Thank you, Neha. So we have created 2 visualization using Tableau. First report we have created, which shows graphical representation of clients, location, and moreover, other report shows tree, which shows total sales of top clients. Moving forward to other visualization report.
Hey guys, hello.
With
Sorry to interrupt. Your time is up.
thank you, Shreya. Just 1 minute, or like 30 seconds maybe. So the other visualization report, which shows Power BI, there are 2 types of two types. Like the first report is a bar graph, which is for total sales per billing month, and other pie chart report shows total cost of the product. Thank you. So, is there any question for us?
Yeah, I just have one question. So I just wanted to know, how are you checking the quality of the product?
Whenever there is a new entry, so we have added a constraint called as quality check, so that the product which has not passed the QA test will not be added to the table.
Okay, so that is there for each product.
Yes.
Okay. Oh, that's it. Thank you.
Great work from Team 5. Thank you, Team 5, and thank you for the question. Let's welcome Team 6.
Good morning, everyone. My name is Minxi Han, and I'm a part of Group 6 in Database Management and Database Design. And today, our team will be present on the Fitness Part Management System. First is the database purpose. The fitness parts management system could help fitness professionals with the tools they need to manage their employees, members, classes, and also online schedule system. And also providing member with the flexibility to schedule class and also enroll online. And we also work for the business rule based on the employees, class, compensation, and so on. And next one, please. And also the database address like several business problems, which include like efficient employee management, limited membership plans, inaccurate compensation calculation, and also lack of flexibility for members. Next one, please.
So our ERD is mainly consists of two major components. The first one is the employee and compensation management, which is highlighted in red. Another part is the fitness member scheduling and payment services. They all connected through the instructor class. Next, please. To comply with the third normal form, we introduced associative entities to better solve the many-to-many relationships between their parent entities. By conforming with third normal form, we anticipate our fitness pass management system can greatly improve the employee and member management for the business and maintain efficiency when querying data for the business needs. Next, please. We also introduced computed columns in class entity and the instructor entity to enforce our data integrity. So next, let's invite Yunjia to introduce our views.
Our team created 3 views for reporting purposes. The first one is the one to get employees with most performance bonus. We use 2 tables and filter for performance level that is greater than 5 to get the list of employees matching the requirement. Next, please. The second view is to get the class instructor information. We connected 3 tables, instructor worksheet, and class to see what class any instructor is teaching. Next, please. The third view is to get the members' class enrollment information. We joined member registration and class, and then you can see what class a member is registering to. Then Lin will introduce our constraints in detail.
We set constraints according to our business plan. For the table level, we check the members' registration to see whether the class have availability for the newcomers. And for the monthly timesheet part, we check the total work hours of each employees because it should less than 160 hours per month. For the yearly compensation, the yearly bonus should less than total salary, and the class duration should between 30 minutes to 1 hour. For the enrollment capacity, the class capacity should between 10 to 30 people, and use the class and the remaining class should not more than the subscribed class, and the number should not be negative. Then we'll continue to introduce our visualization.
Okay, let's talk about the data visualization and the reports. We use the Tableau to create it. And we can see in the left picture, we talk about the enrollment capacity. The enrollment capacity for each class, with as we can see, the CrossFit have the highest capacity of 30 people. And in the right picture, as we have 3 member subscribe plans. So in the right picture, we show that the count of member for each member subscribe plan. And then we showed that the employee total work hours, the attendance analysis of the employee who is not the instructor shows that the average attendance hours of the overall employees are 128 hours in a month. And we also showed the top bonus employee. And then we analyzed the monthly salaries of different departments. And that's all. Thank you. Oh, sorry for it. And we also talked about the comparison of class hours pay and the office hour pay among different departments shows that personal training class hours pay and the office hour pay are higher than other departments above the average. So as you can see, we have the different departments. There are, we shows that there are 5 department for it, and the personal training is the most important part of our fitness management systems. That's all. Thanks for your listening, and if you have any questions, feel free to ask us.
I have one question. What is the significance of used class and remaining class that you've used?
Sorry.
Oh yeah, I can take this question because we sell the kind of fitness pass. Each pass, for example, the golden pass will have about like 60 class, and then we will count the unused class and the remaining class. For example, each used class will be 10, and the remaining class will be 20. So our members could know like how many class left for them to use.
Okay, thank you.
Yeah, thank you for your question.
Thank you, Team 6. Great work from Team 6. I like your slides. Thank you for the question. Let's welcome Team 7.
Okay. Hi, good morning, everybody. This is Project Team 7, and we'll be presenting our project on a career management system. As we all know that the recent layoffs have left many individuals in a very difficult position, and we're all struggling to find newer opportunities. That's where our database comes in. Our purpose is to maintain data of candidates, recruiters, as well as jobs across various domains based on their skills, requirements, and availability, thereby creating a platform for interactions and connections for everybody to land their dream job. With this database, job seekers will have access to a wide range of job opportunities, resulting in a win-win situation for everybody involved. As part of our application, the 4 pillars that everything is dependent on are the recruiters, the organizations, the candidates, and the jobs. Primarily, there are 10 business rules, among which the job will be related to one and only one job category. The candidate will be allowed to apply to 0 or many candidate job applications. The recruiter and candidate job application will have a one-to-many relationship with the candidate evaluation table. And I'll hand over to Akshay now to explain the entity relationship diagram in more detail.
Oh, thanks, Neha. I'll be starting with the entity relationship diagram. According to the business rules presented in the previous slide, we have created our entity relationship diagram. So we have primarily focused on keeping the IDs as the primary keys for all our tables. The 3 main entities of our ER diagram is the job, the candidate job application, and the candidate evaluation, where the evaluation will be performed by a recruiter. The job is connected to category, position, organization, platform, and recruiter with a many-to-one relationship. The candidate job application is connected to candidate, where we track the information of each candidate. It is also connected to document application and application test with a one-to-many relationship. The application status change is also one of the main entity which tracks the application status change of each candidate through the candidate job application table. Yeah, next slide, please. We have also used DDL SQL commands to create and insert tables, which is basically the database implementation. Here is an example of our database implementation where we have created the job position table and inserted few values into it. So we have also encrypted few columns using a master key and using AES 128 algorithm. Here, as you can see, we have encrypted the phone number column of the recruiter table and also the phone number column of the candidate table. And yeah, this is about the table encryption. Handing it over to Harshini.
In order to maintain the data integrity in our database, we have implemented some table constraints, starting with the number of in the job table, we have the validation on the number of openings and a validation wherein we check the job start date is beyond the job posting date. And we have also implemented constraints with respect to the data of the candidate and the recruiter, wherein we check the validation of the email address if it is correct. And we have also implemented functions in order to check the score and the test durations in the online assessments entity, wherein we check the max score is greater than 30 and less than 100, and the test duration is greater than 0 and less than or equal to 60. This is one of the example wherein we have inserted data which was not correct and the duration of the test was greater than 60, and this is the constraint check that we have done. Moving on, we have also a computed column wherein we check the age of the candidate based on the date of birth that has been entered in the entity table. Yeah, moving on, we have Raj continuing with the views.
Hi all, I'll be talking about the views today. Our first view, essentially all our views use the 4 pillars of our database. So the first view uses the organization job category, and it essentially creates a view of the job openings. So here Acme Corporation has a total of 3 openings for the job name database admin for job category IT. Here is our second, which is the application tracker. This is the most widely used view in our database. Essentially here we use the candidate, job, application status change, and recruiter tables to create a view. And here we can see that the application tracker for each candidate. So John Doe for job name software developer, and the application status is offer extended, and the recruiter name Jamaica. This is moving on to the third view. The third view is the hiring statistics. Here we can essentially see all the statistics of the number of students or number of candidates hired, rejected, under review, etc. Moving on to the fourth view, to Madhulika. The fourth view is application status. Here we join the candidate, application status change, and application status. And using this, we can see the total of number of applicants placed and yet to be placed. Moving on to Madhulika.
For our visualization part, we have used Tableau and created graphs based on the view. For our first graph, we have used job opening details by organization for our data as our data source, and used stack bar graphs, which shows organization name, job category name, job name, and total openings. For example, in Acme Corporation, there are 2 job openings with 3 different job names with total openings with different openings. The maximum opening is 7 and the lowest is 1. For our next graph, which is based on second view, we are using hiring statistics as our data source. We are using horizontal bar graphs to create the visualization. The highest is 8 and the lowest is 1. For our next graph is our application tracker based on our third view. Yeah, just a second. Third view, and it shows like the recruiter's name. Under the recruiter's name, there are first like the names of the candidate and job names and the year of application and their application status. Next is the dashboard. It includes all the graphs with the additional information of placement, how many applicants are placed and candidates are yet to place. That's it. Thank you. Anybody has any questions?
Hi, thank you, team. My question to the team is that how a candidate is evaluated based on the database? Like, what are the criteria for evaluating a candidate?
We use the online assessment table to review candidates and move them further in the process of the interview.
Thank you.
Thank you.
Great presentation from Team 7. Thank you, Team 7. Thank you for the question. Let's welcome Team 8.
Good morning, guys. This is Group 8. Our topic today is Online Course Platform Database. The purpose of the database is to serve as a centralized storage and retrieval system for online course data. It offers a variety of views and functions that will be later used for data monitoring and analyzing. We address 3 business problems here. User management. We manage and monitor data of user orders. We set up customized promotion events to the target audience. Product management. We track KPI on user course performance and predict product performance to manage the future discount. Shopping process. We track the order payment data and implement purchase rate implement plan later on.
Okay, so next is about the entity relationship diagram. Our final ERD contains 14 entities. There are 2 things I want to point out. One is the relationship between promotion and course. We regulate that only one promotion can be used for a course or not. In addition, there is a one-to-one relationship between users and the cart, and we set up the data encryption for user password column later. Next page. I will briefly introduce our SQL statement. We create table for each entity. Here is the example for creating promotion table. We have confirmed the data type and set primary and foreign keys for each item. The result is shown below. Next page. And then we added data by SQL insert scripts and input at least 10 rows for each table. If run the coding for promotion data, here's the result we got. Next.
We got 3 items in this project. Next. The first one is the column data encryption. We encrypt the user password in the user table, and we store the hashed password to the database to secure the user information. Next. The second one is table level check constraints based on function. We create a check max price function, and this function will constrain the max price for a single course when we add a new course. Like when we want to insert a course with price 99, it will suffice, but when the price is 101, the insert will fail. And the max price can be changed as needed. Next. The third is computed columns based on function. We add a computed column called the discounted price in the course table. And we can get the current price by multiply the price and the discount percentage to get it. Next.
So we come to part 4, views with encryption and schema binding. Next. We simply create a multi-table view first. Like we create view course info, and we can select all from this view. Next. We create view with encryption. So encryption will protect the view query definition, and this view definition won't be visible to other users who don't have the necessary permissions. And we can select the certain columns from this view, as the result shows. Next. We can create view with schema binding. Like we create the view order details and bump this view to the schema of the underlying tables. If we want to modify any related column, we must remove this view first. Like we want to drop order time this column, it will remind us the view is depend on the column order time. Next.
Okay, so we have 2 parts in our data analysis result. The first part, next page, please. The first part is purchase analysis. From the graphs, we know facts like where are the most highly valued users and what courses categories will be easier to sell so as to improve our purchase rate. So for example, in the first graph, we see that people from New York State have bought the most courses. And in the graph 2, we see the purchase rate for each course category, which is very useful in problem finding and new courses development and so on. Next, please. The second part is feedback analysis. We can get some insights about course quality and experience feedback from users, completion rate, and average review points for each categories. So for example, in the first graph, art and physics course has the lowest rate of completion, which means the courses are not satisfying now. So we know where to modify it and update. So thank you for listening, and you're welcome to ask any questions.
Hi, teammate. I just wanted to know how you're ensuring there's only one promotion been applied for a course.
Sorry, do you mind repeat that question?
How are you applying promotions for a course that's been bought?
I think we will apply promotion based on the most rated course and also the higher purchase rate.
Okay, thank you.
Okay, great work and the presentation from Team 8. And thank you for the question. Let's welcome Team 9.
Hi everyone, this is Team 9 and today's presentation is about healthcare management system. This is the overview of the overall project presentation, and starting from the objective, the healthcare industry has always faced the challenge of consolidating patient data and healthcare information in one place. Unfortunately, this usually results in loss or mismanagement of critical information. In this project, we aim to provide a comprehensive and integrated database system for healthcare management system to improve patient information management efficiency. This is the list of our business mission, including that this system would enable healthcare workers to support patient and provide better service and treatment. It also provides easy access to patient information for authorized healthcare providers and also support a clinical decision making by providing relevant patient information. Here is the ERD diagram. In the ERD, we consolidate the patient database based on one primary key, which is a record ID in a medical record table. Using record ID, you would be able to access all the necessary information of patient, such as the hospital they've been admitted, the medical record, insurance plan, and their medicines for better, to provide better service. So, and following a slide will be continued by Kushagra.
Hello everyone, I'm Kushagra. We have implemented several table level constraints to ensure data accuracy and consistency. This constraint include function to validate zip code while inserting patient data. This function checks whether the zip code consists of 5 digits. The next function checks whether contact number is in correct format and consists of 10 digits. Next slide, please. The function checks whether the email is in correct formats and ends with .com. The next function checks whether gender is male or female. Next slide, please. The age is validated by another function which checks whether age is positive integer between 1 and 100. A function to validate discharge date greater than or equal to the admit date. This constraint ensures that the data in the healthcare management system is accurate and consistent, which is crucial for providing high quality healthcare services. Over to Shantanu.
So we are generating columns on the fly. So first computed column is for calculating the age. So based on the current date, we are calculating the difference from the DOB and we are generating the age of the patient. Next. Second column that we are computing is the billing, total billing amount. So we are taking in room costs and other charges for a particular record, and based on that particular record, we are getting the appointment cost, the total cost, the medicines cost, and we are just returning that in a new column called billing total.
So in our patient data, we had some sensitive patient table. We had some sensitive data like phone number and email address, which we are encrypting using symmetric key encryption. We are using the AES-256 encryption algorithm, which is the standard SQL algorithm for that. Next slide, please. So we have completely automated the encryption process. We have created a trigger based on a insert on the patient table. So whenever a new row is inserted, the trigger will get executed. And we are also opening and closing the symmetric key in the trigger itself to achieve complete abstraction. Like unauthorized users won't have access to, neither they'll be able to see the symmetric key. Next slide, please. We also have created a stored procedure to decrypt the data. We have the select query and also the opening and closing of the symmetry key inside one DB object. So again, we can directly execute the stored procedure without opening and closing the symmetry key. Over to you, Shantanu.
We have created around 8 views for this system. For reference, we have just added 2 views. First one is for getting the patient billing details. We are getting so we are using horizontal report formatting for this view, and we are getting all the tests and all the medicines that were assigned to a patient in this view. Next. In the second view, we are getting all the patient details and the vital signs of that patient for that particular visit. So this is related to what vital signs were there for a patient when he came for a particular visit. Next.
Here you can see sample visualization of our developed database for hospital point of view. Left figure shows number of hospitals per state. As is obvious, California and Texas have the highest number of hospitals. The right figure shows the patient number for top 5 hospitals in Mass. The Mass General Hospital has the highest number of patients. Here, next slide, please. Here you can see visualization from patient point of view. The top figure shows the insurance coverage for our patients. Most of the patients are covered by employment-based insurance, while a few of patients are uninsured. Bottom figure shows the total disease burden by cause. It shows that the majority of patients, around 50%, have cardiovascular disease, followed by cancer with 10%. Next slide, please. Thank you all for your interest and attention.
Yeah, I have a question about the computing age. I want to know the reason why you're computing the age, and is there any relationship between the age and the billing?
There is no relationship between age and billing, but yeah, we are computing age on the fly. So the user can directly type their date of birth and the system will automatically calculate their age based on that. So that like they don't have to add an extra field.
Okay, thank you.
You're welcome.
Great work and a presentation from Team 9. Thank you, Team 9. I think for the question. Let's welcome Team 10.
Good afternoon, Professor and all my classmates. We are Team 10 and our project topic is City Bike Management System. I'm Krupa and my teammates are Sejal, Shubham, Rishabh, and Abhishek. Moving on to the overview of our project, just like we have the blue bikes in the city of Boston, we have created a similar database on City Bike Management System, which has a fleet of 393 bike station and 3,800 bikes, which is easily available and affordable. We found out that higher usage of bikes led to higher inefficiency in ride booking, and we proposed a better and efficient RDBMS system. Moving on to the problem statement, we faced a persistent payment issue and slow loading of the application. We also faced an additional problem of fare calculation with time duration and membership mode of membership and discount coupons. To solve this problem, we provided a membership option, weekly, monthly, and yearly pass. And we also created a data encryption using symmetric key for privacy of coupon code. Moving on to proposed solution by Abhishek.
So hi, the proposed solution is that we've created an entity relationship diagram with tables and entities to explain the relationship between all the tables. We've created database and tables using DDL statements and inserted data into the table. We've applied table level constraints, data encryption, and computed columns to check the table and the databases. Along with that, we've implemented function views and triggers in our database as well. So this is our entity relationship diagram. We have a total of 12 entities, and we've represented that using a Crawford notation in our entity relationship diagram. As you can see, there are dotted lines which represent the not identifying relations, as well as we've added certain associate tables which create a identifying relationship between tables. So we've added all the 12 entities in this entity relationship diagram to create our database. Moving on to Shubham for the technical aspects.
Yeah, so apart from creating and inserting the data, we have also created store procedures, functions, sequences, triggers, different reporting views, then functions for table level check constraints, functions for computed columns, and data encryption. So moving ahead with the stored procedures. So these are the stored procedures we created in the database. With the use of these stored procedures, we can create all the objects in the database at once. Even we can clean up the database using the cleanup store procedure. Along with that, these are the functions that we have used for table check constraints and computed columns. Then these are the sequences. So for sequences, we have used sequences as it can generate not null and unique values for the IDs, which is a primary key for our tables. Along with that, this is a trigger that we have created in which if we change the coupon code value, then it will create a new table with the old value as well as a new value for us to track the data. Moving it with the views and data encryption that Rishabh will explain now.
Yeah, so for maintaining data privacy, we have used data encryption on the coupon code, the coupon code. So we are using the symmetric key and AES 256 algorithm for the data encryption. And while encrypting while inserting the data, we are using encrypt by key function to convert that varchar into var binary format and store it in the data. And while decrypting, we are again converting using the decrypt by key function to get the coupon code name and convert it into varchar. And moving on to views, we have created 6 reporting views for reporting purposes, where the views are such as number of bikes available at the dock, number of bikes available at dock, and then the customer membership status, where we are having a table we are creating a view joining the membership and the customer table, and also to maintain the ticket queue details of the created by the customer. The 4th view is basically regarding the technician repair and the details, and 5th is regarding the bike models that are available and number of bikes, and the last view is basically the number of rented bikes. So further on, we will use visualizations and in Tableau, which are explained by Sejal.
Okay, so based on the database, we have created a dashboard using the Power BI. In the Power BI, you can see that we have created a dynamic dashboard in which we can select one day. And when we select one day, then the data changes automatically. So for example, if you go to one day, then you can see the first one in which it is the rental duration versus the customer balance. So the more the rental duration, the more will be the customer balance. The second one depicts that the bikes are located in the Boston location. The third one represents the number of docks available as well as not available based on the location. The fourth one represents the tickets that are assigned, that is the assigned tickets as well as the closed tickets. Here you can see that the number of docks are 10, the available bikes are 3, the total bikes are 5, and the customers are 5. And if you can see, the City 2020 is a model. For one day, most bikes are available for these models. These are the KPIs that we have used. And if you click on the one day again, you can see this is the overall dashboard representation for the entire database. Also, we have created the report in the Tableau as well. For the Tableau, we have used a table level format. In this, there is a ServiceNow ticketing tool, which represents the ticket ID as well as the ticket details, and the customer membership tool as well. I will forward to Shubham for the demo representation.
Now a quick demo about our database. So the function, the key feature is that we can execute all the commands with a single click. So we have followed all the company structures and everything. So this is everything executed at once. We have created store procedures, functions and everything at once. I'll just refresh and I'll show the details as well. So if we refresh the server, go to databases. If we go to City Bike demo, so we can see like all the tables and views, everything are created. And just like, if I'll show you all the functions, what we have used.
Sorry to interrupt you guys, but your time's up.
Okay, like these are the functions of the column, computed columns, and the encryption and everything. Thank you so much.
Thank you.
Thank you, Team 10, for your presentation. I have a question. How does your system handle the tracking and monitoring of the bike, and what methods are you used to prevent like theft or loss of the bike?
So it uses unique constraints thing for like we have different teams that take care of that. We have an agent team which takes care of all the maintenance and thefting of the bikes. We have a table for that, and there are certain ticketing queue table which has requests and everything. So if a bike is lost or not there in dock for more time, then there will be a request in that ticketing queue, with the agent will take care, and then we'll track the things.
Okay, thank you. Thank you for your explanation.
You're welcome.
Team 10, I had another question. So in the ERD, I was able to see that you guys have kept features like if a bike is not in a good condition, there's an option for repair, right? So how are you guys checking that if the bike is under repair, an end user should not be able to select it?
Like, so yeah, the agent, like what I told, the agent team will take care of it, and they will have a function that will mark the bike as not functioning, and then we can then like it won't be accessible to customers for that. Then they cannot select the bike using that thing.
Okay, and each agent will be assigned to just one bike, or he can take care of multiple bikes?
Like at once one bike, but they can take care of multiple bikes as well. So it's not a unique column for us. Like agents can have multiple tickets under their queue.
Multiple active tickets, because I was able to see a PK-FK relationship between these two.
Yes, if you'll see, like they can, it's not a unique column. If a PK-FK relationship is there, but it's not a unique thing for the ticket description, which is the separate column for us. So they can have different ticket IDs in our agent ID. So the agent can have different ticket IDs in there.
Okay, thank you.
Great work from Team 10, and I like your left demos on visualizations and the reporting. And thank you for the question, a great Q&A. Let's welcome Team 11.
Okay, so I'll go through the ERD. So our ERD contains all the entities defined in the project scope. We have the users table, which is the main table. Am I audible?
Yes, you are.
Sorry,
Yeah.
you are now. Okay, awesome. Continuing. So the user table contains attributes such as the username, profile picture, bio, followers count, and media name. The followers table contains the follower details, and the user login table contains the user activity in terms of login and logout times and the duration spent on the app. Other important tables include the media and interactions table, which are responsible for tracking the stories, reels, and posts uploaded by users, and the count of the likes and comments on them respectively. We have carefully separated the entities and connected them using a series of primary and foreign keys along with specific constraints. Finally, to track trending hashtags and filters, we have generated separate entities and used associative tables to connect them with the media table, such as the media hashtag table and the media filter table. Sorry. We also have a tag table which connects the users and the media table. Moving on to you, Rani.
Hi, Professor, and hi, team. We cannot hear your presentation.
Hello, am I audible? Hello, am I audible?
We are getting
There's a
sound.
little bit echoing, so just check your audio, please.
Yeah. So we have created table level check constraint. So we have created a function check user sentiment where it checks whether the comment is negative, and we have added a check constraint. If at all a user has more negative comments, then we are not allowing him to comment again. And our threshold is 7 here. Passing it on to Shishwa.
We created a stored procedure to get the top 5 influences based on the followers count. Coming to triggers and functions, we have created a trigger to calculate the like count based on the interaction type, where interaction type equal to 1 is considered as likes and interaction type equal to 2 is considered as comments. This function is called by a trigger whenever values are inserted. Similarly, we have created for comments count and as well as interactions count, where interaction is a combination of likes plus comments. One more trigger is to update the followers count in the user table, and the duration, that is difference of logout and login time, is calculated on user login table. The last trigger is to insert posts, stories, reels in the respective tables based on the media type. If media type equal to 1, it is considered as a post, and if it is 2, it is considered as story, and if it is 3, it is considered as a reel. Similarly, we created a trigger to insert likes and comments in the respective tables using the interaction type. Now over to Hinal.
Hello, good afternoon, everyone. So we have created 6 views. Out of 3, I will explain, and the rest we have used for data visualization, which will be explained in the next slides. So the first view is hashtag counts, which determines the trending hashtags which are used basically for brand visibility. The second view is most visited locations. Since we make most of our decisions based on Instagram, where we have to visit next, so hence we created one more view for the most visited locations. And the last view is the sentiment of the comments, which basically on every interaction we can track the sentiment of every user to see how the brand is impacting. Passing over to Vamsi for next views.
Yeah, hi everyone. We have created the visualizations for the views. So this is one of the views which I've created, which is called popular Instagram influencer, which shows the top 5 influencers or the top 5 users who have the highest followers. This is the sentiment analysis on which the user negative and positive comments are calculated. And also this graph depicts the highest number of hashtags which have been used by the users. And here we can see the past 1 year users which are having the followers count.
Hi guys, sorry to interrupt your time.
Okay. Yeah. So coming to the future scope, if we were having more time, we would be working on Instagram business entity to learn how business utilizes Instagram for marketing purpose. And also we would have added more data so that the data analysis would be more meaningful. And also, as we can see that there are many queries to be executed, and it takes a lot of time to execute all these queries. We would have used ETL tool in order to automate the entire process. So it would be very easy to use. So these are some of the references which we have used for a project. Thank you.
Yeah, hi. So I have one question. As you have represented that you have created a trigger to calculate the top 5 influencers. So I just want to know what are the parameters on which they are calculated. Like, is it only based on the followers, or the likes and comment counts on them also are considered for that?
We have used only followers count.
Okay. So, but I just wanted to know if if you are maintaining the likes and comments, so are they not making any impact on the person's influence, like how?
Yeah,
Because
so
that's what is considered.
we have used engagement rate as well. So that's another chart.
Okay, got it. Thank you.
Yeah.
Thank you for the presentation and the work from Team 11. Thank you for the question as well. Now we are almost halfway through the presentation, and we are doing great with both the quality of the presentation and time management. Thank you for your contributions. Let's welcome Team 12.
Good afternoon, everyone. This is Team 12. My name is Ishita,
and our topic for today is Cloud Kitchen. So Cloud Kitchen is a restaurant idea that does not have a typical storefront or eating area. Instead, it uses online ordering and delivery platforms to collect orders and deliver food directly to the clients. So in this application, a user can order food online in a particular delivery zone, and there is a pickup available as well. So the main advantage of cloud kitchens is that they enable food enterprises to operate with reduced overhead expenses than traditional eateries. They also provide greater flexibility and scalability. Next slide. So the cloud kitchen consists of three systems: the kitchen management system, delivery management system, and order management system. Over to Sumant.
Hi. So the core part of any cloud kitchen is a well-executed delivery management system. In our model, we have executed the efficient delivery system where we have segregated the address of customer, kitchen, delivery drivers, and collection points into zones. We have also created a trigger to assign delivery drivers to order, which triggers whenever an order has been placed. Along with this, we have created a table level constraint which verifies whether the customer belongs to the zone as kitchen. Next slide, please. The other key feature of our model is the order management. We have divided this feature into three parts. The first part is the customer management, where we are storing the customer personal information, and each customer can have multiple addresses. The second part is the order management, where we are capturing food items which are related to a particular order. The last one is the review management, where a customer can give a review which is associated to an order. Over to Unnati.
Hi. Integral part of our model is kitchen management system. As we know, kitchens that cater to different cuisines need different kinds of equipments. To cater to this requirement, we have created a separate equipment entity, and we provide a kitchen equipment association entity to store information for all kinds of equipments used for a particular kitchen. We also have a real-time computed column to find the average rating for each kitchen based on all the reviews submitted by the customers for that kitchen till date. In addition, we also have a real-time computed column to find the most ordered food item for each kitchen. Next. Next, to cater to the possibility that the database will be used for a UI search feature in the future, we have implemented our food item entity in such a way that the customers are able to search food items on the basis of cuisine, diet type, that is veg, non-veg, vegan, according to the preference, or dish type, that is according to the appetizers, desserts, and main course. Next.
So the next part of that is our people management system. What we have here is, because we are storing different kinds of people's data, we are creating core entities such as contact, person, and address that can be stored across different people. Now, when it comes to contact, the contact is used, a single contact table is present to store all the contact information, and it's associated to the person. And for each person, we have two different types of persons. One is delivery drivers and customers. And similarly for address, we also have a single code table that stores all the information about the address for kitchen, could be the delivery driver or the customer. We also have an association for customer address where, because each customer can have multiple addresses, there's an associative table that that stores the information for each customer. Next, I have our ERD diagram. So on this ERD diagram, you can see over here, we have the information on the tables that cater to the delivery. Over here, we have things that are related to the kitchen and the information and what they're serving. And here we have the order management system, which includes how are the orders being done and what are the reviews for that. Next, we have a sample of the tables that are created. And these are the two views that we are creating, one each for delivery zones, and to get a picture of what's happening on each of the zones. And also on the right, we have a kitchen review view. Here we are trying to get an understanding of what how our kitchen is performing and the distribution of different ratings that we are getting. Next, I'll pass on to Shubhi.
So the zone analysis dashboard here, based on the zone ID selected, represents the address of the zone ID, the number of kitchen present in that zone ID, the highest rated kitchen, number of delivery drivers, and the graph below represents the average order placed per day in that zone ID. Next slide, please. So this is the kitchen analysis dashboard. Based on the selection of the kitchen ID, it presents the kitchen name, most ordered item, and the number of reviews. The graph below represents the distribution of ratings for that particular selected kitchen. Next slide, please. Thank you. Any questions?
Yeah. So in your presentation, did you use triggers?
Yes, we have used one trigger. So in one of the trigger which we wrote is to assign a delivery driver to an order. So where when an order is placed, our trigger will check it will collect one of the driver from the particular zone, and it will add a record in deliveries.
Okay. So how are you calculating the rating? Is it manual or will it automatically update when a new record comes?
The rating will automatically update because it's a real-time computed column. So whenever you select information about the kitchen, the current data that is present for the orders will get rating.
Okay, and is there anything that was was there any future scope in your project?
You're not audible. Can you repeat your question, please?
Am I audible?
We
We are
can't
not
hear
able.
you.
Yeah.
Can't hear you if you're speaking.
So is there any future scope of your project?
For the future scope, we can, one of the things that we could possibly implement is having the information of how the kitchen is performing, and especially on the capital side, with the revenue and our expenditure. That is one thing that we wanted to add if we have more, if the scope could be increased.
Okay, thank you.
Thank you.
Thank you for your questions.
Yeah, I have a question actually.
Yeah, sure, go ahead.
Mentioned real-time computed columns. Like, what do you mean by real-time exactly?
Yeah, that just means whenever you fetch information about any kitchen, it will it is not already stored in that. Like it will take all the orders from the orders table and then calculate. So I meant that.
Okay. All right. Okay.
Yeah.
Great work and the presentation from Team 12, and thank you for the questions. Let's welcome Team 13. Team 13, please.
Maitri, you are not audible. Can you please unmute yourself? Can you start, Maitri, maybe? We'll let you know if you're not audible.
Maitri, can you connect with computer audio? Maybe it is a Bluetooth issue.
Hello.
Yeah, you're audible now, Maitri.
Oh, sorry everyone. There was some network issue. Is my screen visible, guys?
Yeah, it is
Yeah.
visible.
Okay. Hello everyone. We are team 13 and our database topic is car rental system. So the purpose of a database is to maintain all the booking informations of the rented cars, where customer can access all the information of available vehicles along with their models, and admin can access an additional information of vehicles along with customers' feedback. So the business rules are: a customer should be a minimum of 21 years of age with a valid driving license to make a reservation before renting a car. So a car can be rented only by one customer at a particular time. The personal data of customers are corrected, but they are stored in compliance with data privacy laws. If a customer failed to return the car, he will be charged with late fees and penalties. And customer can opt for rental insurance, and if they have one, but if they don't have, they can buy it while booking. So a design document, we have 15 entities. So majorly the booking info and billing entities collect all the booking information of the customers along with their final amount of tax and late fees. We also have vehicle and vehicle categories which stores the information of different available vehicles along with their models and total price for per hour. We have other entities like rental insurance, customer review, customer support, and status of the customer support. Over to you, Shruti.
So this is our ERD diagram. When a person logs in, they can see information about all the available vehicles for renting, and they can book any vehicle by entering start date and return date. When a trip ends, the actual return date gets updated, and along with that, total rented hours is being computed. Apart from that, we also have entities such as customer support and customer review and vehicle maintenance records so that we can provide a quality user experience. In the next slide, you can see the stored procedures that we have created to insert data into our table. We have implemented such procedures for almost all of our entities. And in the next slide, you can see the stored procedure that we have created to check whether a username exists and the password is matching to that particular username when any user tries to log in. Further, Palak would take over.
Yeah, so we have introduced table level check constants in our system. One of them is checking age of a person. On a left-hand side, you can see that we have created a function that calculates age of a person based on the birth date. The check constant is added on the displayed on the right side. If the age is less than 18, then it will not allow the user to insert the person record, and an error will be thrown, which is displayed below. Next slide. We have implemented 4 views in our system. In the first view, we are displaying the booking IDs in a horizontal format, where the duration of the week will be, if it's 7 days, more than 7 days, then the output will be displayed on the view. In the second view, we are showing the location, which has most of the bookings. We have used the top clause in the ties keyword to implement it. As you can see on the right-hand side, we have vehicle ID and average rating. In the average rating, we are showing the average rating of each vehicle with the help of average function. In the fourth view, we are displaying the details of the employees who has resolved the most number of tickets, where we have used count function over here. Over to you, Aisha.
Yeah, so next we have created a trigger on table booking info status, which is on insertion. So whenever customer confirms a booking, there will be an entry created in booking info status table. So basically this will generate an invoice, which will further create an entry in billing table. So while creating an entry in billing table, we'll insert the total amount, the tax, the late fee, and all these the total amount and the late fee will be calculated by using a function get total, which we can see here. So basically this function get total amount I mean, the two columns, total amount and late fee, are computed columns, and we are using this function to calculate those. So we have the start date and return date and the actual return date. So now whenever customer returns the vehicle after the actual return date, we'll charge the late fee cost, and hence we'll calculate the total amount and late fee accordingly. So over to Ketki.
Thank you, Aisha. As you can see, we have implemented column level encryption using symmetric key. We have encrypted the password and the driver license.
Guys, time is up. Sorry to interrupt, but the time is up.
Yeah, we had audio issue, so that's why the time is up. We still have like 1 minute.
We'll be done in like 30 more minutes.
Okay.
So you can see we have done data encryption using symmetric key. We have encrypted two important columns, which is password and driver's license, as we believe those are some user critical information. Next slide, please. We have used Power BI for data visualization. We have like 3 reports created here. One of them is the map, where you can see that we have highlighted the areas with the most bookings. Then you can see we have a pie chart here, which shows the percent of vehicles which are booked. And the third one is a bar chart, which shows, which helps with the analysis of customer review. This is all about a project. Thank you guys, and we are open for any questions.
One question I have was, you mentioned you're calculating age and then selecting, and would that be updated in real time, or would that be a static field?
So the age we are calculating, it is automatically updated in our table, and the user just has to give the input of his date of birth. That's it.
Okay. Also, maybe another question is there anything that you plan on doing, like in case you get more time or something like that?
So there is one thing we can do is, maybe the thing about discount. But so we were like, that is one thing we would have implemented if we had more time, is say, there are some coupons or something these days. So the discount entity would have been something we would have added.
Got it. Thanks for that.
Thank you.
Great work from team 13, and thank you for the questions. Let's welcome team 14.
Thank you, Professor. Good morning, everyone. We are Team 14, and we are presenting a project known as GrowGo. Our motto is groceries at your doorstep. Our team includes Asta Prashar, Tiyasha Sen, Sangram Bhupala, Kashish Desai, and Akhil Maladi. Our agenda goes from objective to entities, to technologies used, visualizations, challenges, and then summary. Our objective is to develop an online grocery delivery system that allows customers to purchase and receive the groceries efficiently at their doorstep. They are also allowed to browse their preferred categories online and can also apply for promo codes and rewards. We have 17 kinds of entities. We have also used a lot of DDL, DML queries, as well as in functions, triggers, and stored procedures. Here you can see one of them, that we have used table address, where we are using table level check constraint, which is checking if the zip code is valid or not. And we have also used create stored procedure to insert data in the address table.
So these are the display tools used to develop our project. We have used Lucidchart for the design and implementation of ERD. We have created tables, views, stored procedures, and performed database implementation using DDL and DML commands in SQL Developer and also dbeaver. Also, Power BI is used for implementation of visualization, charts, and graphs. Next, we go to the ERD implementation. The ERD implementation for GrowGo has been done using crow's foot notation. In this ERD, we have included all the foreign keys needed for a particular entity. Also, the relationship has been identified between the entities, whether it is identifying or non-identifying one. Also, here we have associative entities, which removes many-to-many to one-to-many relationships. Next, we have used data encryption on user details and also payment card details table. Encryption has been applied on the user login password and card details for the particular user. Next, Akhil will continue with calculated columns.
So, hey guys, so we have some columns which are dependent on other columns, such as like items value or cart value or bill amount. So to calculate them, we have used the stored procedures, which calculates them upon the insertion of the data and updates them. Here you can see the cart item value being calculated and cart value being calculated. Hey, can you go to next? Yeah, here insert bill amount being calculated. You can see like how we are calculating it. Total amount is equal to, we are like negative, removing the discount, and then we add the delivery fee and all. Next one. So we have implemented two triggers. One trigger is to update the product stock quantity. So whenever a customer or places an order, we check for the number of whatever the product present in the order and whatever the item quantity present in the order, and we decrease the item quantity from the branch product. So thereby we can restock it when we are out of it. That's one trigger. And second trigger is we are writing a trigger to encrypt the payment card details upon insertion. Can you go to the next slide? So yeah, whenever user want to fetch his user card details, now we are trying like a stored procedure to decrypt the encrypted store card details to display them to him. Like, yeah, now Sangram will continue.
Yeah, thank you, Akhil. So I'll be talking about the business problems addressed and the visualizations. So these are the business problems which we have addressed, and I'll be discussing these in the further views and reports. So coming to the branch performance, so we have graded branches based on their revenue generation for the whole year, and this helps us in analyzing and assessing the branch performance and rewarding the managers of the well-performing branches and giving them any incentives. And coming to the next view, we have so this is the view for the topmost selling products in each category. So in the right hand bar graph, which we can see each category and the respective product which has the most sales in the respective category. So the advantages of this report is that it helps in giving offers and discounts to those products which have high sales, and generally these products are competitively priced, and this helps the customers to make sure that they are getting good value for their money. And coming to the next slide, so these are the detailed statements for the above two views. Coming to the next slide. So this is the top 5 selling products of all categories in all the branches. This report helps in acquiring these products in bulk at cheap prices, and also to renew these stocks very frequently. And coming to the next slide, it is the best performing delivery boys. This helps. We have graded the delivery boys based on their average ratings. This helps. This helps in rewarding the best performing delivery boys. Now I hand over to Kashish.
Yeah, thank you, Sangram. So this view is about the number of orders placed month-wise. So this particular view helps us for find a good time to release promotions and manage delivery boys to be employed at that point of time in the year. Also, like for example, we can see in the month of April there has been the highest number of orders placed. So we can increase the number of delivery boys or introduce promos in that particular month. Next. So here are some of the challenges that we have faced.
Sorry to interrupt. Your
Yes.
time is up.
Yeah, just one more slide. Yeah. So defining associative property among the entities. Then we also face challenges in solving many-to-many relationships, and we had to introduce new entities for that. Also, we had to create business problems to implement functionalities.
Then we also had to sync the data among different entities where referencing was to be used. And we also had to enforce data integration while insertion. Next slide. So yeah, the basic summary of our project is that we have developed an online grocery delivery system that allows customers to browse and purchase groceries online from multiple local stores. So the ERD also includes various entities like we had discussed right now, which are related to each other through identifying and associative relationships. The database also solves many business problems like grading branches and delivery boys. Yeah, so this is it. Thank you.
We are open for any questions. Thank you.
I have a question. I mean, I saw you have added a function to calculate the amount. So I just wanted to check if are you having any filter to, I mean, if there is a specific amount, then only the delivery fee is added, or is it added for each and every transaction?
So we have
each and
added
every transaction will be like we have a delivery fee for each and every transaction. So it will be added on every transaction.
Okay, so there is no minimum or maximum amount, like if it is exceeding that.
No, we
don't charge.
haven't.
Okay.
No, we haven't kept any minimum or maximum amount. Like
Okay,
so,
thank you.
we felt like some basic delivery fee should be added on everything.
So that would be our
irrespective of
future
the
scope. If we had more time, we can add that feature in that.
Okay, thank you.
I have one question. So, why have you encrypted card details twice?
So like we have two like for payment card details, we have used two encryption methods. One is to encrypt already present data in the database. The other is to like we have encrypted using a trigger. So whenever data is being inserted, then it encrypts the data and then it inserts the data. So yeah.
So initially, while we are putting the data, we have encrypted and inserted the data. But later on, now if we insert the any data, it will automatically get encrypted. Like we just have to enter the card details, and it will automatically encrypt it.
But can't we do it like that? Like suppose the table is empty, we have the trigger. So whenever we start inserting, it will automatically encrypt. Why do it twice separately?
No, actually, well, while we started, right, we already had inserted like 20 columns. So instead of like we just dropping the table itself, we thought maybe we will encrypt whatever the details we have added. And from now on, whatever the payment card details that we are being added, we will try to encrypt that. So yeah, by following this method, we had to write two encrypt like functions. So.
Okay.
Yeah, thank you. That's a great question.
A great data analysis from Team 14 and a great Q&A. Thank you, Team 14, and thank you for the questions. Let's welcome Team 15.
Hi everyone, my name is Kishore and we are group 15. Our project is Dishdrop, which is food ordering and delivery management system. So this is our problem statement. So currently food ordering and delivery system is inefficient, which leads to higher customer dissatisfaction. Existing systems do not track restaurant menu items and restaurant inventory, and many focus on customer data only. So for us, the goals are to improve the efficiency and accuracy of food ordering and delivery process, which will lead to higher customer satisfaction. Manage and also to manage data related to restaurant menu items and restaurant inventory along with customer information, which will lead us to efficiently track food delivery order. So this is our ER diagram. Our ER diagram is mainly classified into three things: customer, restaurants, and payment. In customer, we are mainly capturing customer details along with customer orders. And for restaurants, we are capturing restaurant details along with menu items. And also lastly, we are capturing the payment method type. So next, Chinmay will take over.
So here we have implemented computed columns based on function.
The first column is total revenue, which is present in the restaurant table. And this is being calculated using the function calculate total revenue of restaurant, wherein restaurant ID is given as an input. And here in the query, we are using sum of price to get the revenue value for each restaurant. The second computed column is most sold item, which is present in the restaurant table. And this is being calculated using the function get most sold item name, and here the restaurant ID is given as an input. And in the query, we are selecting the topmost item name, and the records are being ordered by the sum of the total quantities of that item, and we are returning the item name. So next we have implemented table level check constraint using the function, wherein the constraint will not allow the user with the same name and email ID to register. And this being implemented using the function check user registered, wherein we are passing first name, last name, and email. And in the query, we are setting the count value to 0, which is getting in case if the email, first name, and last name gets matched with any of the current record, then the count value will get updated, and the insert statement will throw an error. Moving on, Nagarjun will explain encryption and views. Encryption is the process of protecting data by the use of key. Sorry for the inconvenience. Yeah, encryption is the process of protecting data by the use of key and password. We have implemented encryption on password for user in user account table for security reasons. We have implemented AES 256 algorithm for encryption. We have added an extra column to display encrypted password. When we execute select command with an decryption for function implementation, you can see that you can see both encrypted password and decrypted password. We have also created views. We have created 3 views for reporting. View 1 displays the customer with premium account who have placed at least one order. View 2 displays the restaurant which has sold most number of unique menu items in descending order. And view 3 displays the most sold menu item in each restaurant. Moving on, Manoj will take ahead with triggers.
So a trigger is a special type of stored procedure that automatically executes in response to certain database events such as insertion, update, or deletion of a row in the table. So we have 4 triggers in our application. The first trigger is an example of data validation trigger, which is defined on customer orders table. This trigger is designed to prevent orders from being placed after 11:30 p.m. and it alerts the user with an error message if this restriction is violated. Trigger 2 is an example of data modification trigger, and this trigger reduces the inventory of the menu item when a new order is placed. So this helps us to ensure that the inventory levels are up to date and it is accurate. The third trigger provides a mechanism to automatically update the delivery time of a customer order record when its status is changed to delivered. The fourth trigger provides a mechanism to automatically calculate the total price of a customer order record based on the price and quantity of the menu items that were ordered. So we use the aggregate function sum to calculate the total price. Now Sanjay will take over and explain visualizations.
So we have divided the analytics of the visualization as 2 parts. One is the customer based analytics and the other is the restaurant based analytics. So when we come to the customer based analytics, we have included the customer orders to see who is making highest number of orders so we can send them promotions accordingly. And we have included payment modes to see what kind of payments we are receiving the most. And we have also included another graph where we are understanding where the premium customers are ordering more from. Like we can understand the restaurants that are receiving more orders from the premium customer. So this is mainly to improve the business in the future. When we come to the restaurant analytics, we have included what is the most sold items. We have also included the types of cuisine sold to understand where the business lies. We have also included the total revenue made by each restaurant to understand who's doing better. And we have also included another table where the delivery status. So to understand where the products are delivered and also where the orders are pending. So we have done this to make sure that the restaurants are also aware of how many orders they're pending with, and also the admins are aware of what kind of orders is pending. So we have included both these analytics to understand. We've divided it as customer and restaurant to make it clear for the admin as well as the users. Thank you so much and happy eating. So if you guys have any questions, you can start.
Hi, team 15. I have a question for you. You have used a trigger for calculating the order price, right? So could you tell me what events can trigger this calculate order price, and how does it calculate the total price of the customer order?
So yeah, so this trigger can be triggered by an insert, update, or delete operation on the customer order items table, and the logic is it contains an update statement that modifies the price field of the customer orders table, and the update statement is joined with the subquery that calculates the total price of the menu items for each customer order. So we, like I told before, we are using the aggregate function sum and a join between the customer order items and the menu items table, and we use the set clause to update the price based on the calculation we derived.
Okay, thank you.
Okay, great presentation from team 15, and thank you for the question. Let's welcome team 16.
Hello everyone, we're starting now. We are group 16 and our project topic is NU Healthcare Management System. First, I'll be starting with the problem statement. So we want to create a database system to manage healthcare for university students, faculty, and staff, improve tracking, stock management, and patient care with accurate and up-to-date information. Next. The objectives of a project is to develop a healthcare management system for the university with a centralized database to store health-related information of students, faculty, and staff, streamline tracking of doctor availability, vaccinations, and health-related info, and improve patient care with easy access to accurate data. We want to allow users to search and inquire about medication, vaccines, and tests, track appointment history and expenses, and manage insurance claims efficiently. Next, my teammate Kiruba will be talking about the goals of a project.
Yes, so talking about goals, we aim to develop a user-friendly healthcare management system with easy navigation and interaction, which also includes CRUD functionality for managing health-related data, search functionality, appointment booking, and reporting features. We also aim to test the system thoroughly to ensure proper functionality and reliability to address the issues and bugs that could be found during testing. Next. So this is our ER diagram, and the main entities in our ERD is the employees, that is the doctors and nurses, the users, the prescription which is given to the patient by the doctor, and the appointments. So to address many-to-many relationships, the prescription entity has junction tables which detail the vaccines, tests, and medicines prescribed to the patient by the doctor. The vaccine centers, pharmacies, and test centers all have junction tables that detail the available stock of vaccines, medicines, and available tests respectively. Address and employee tables also have lookup tables, and thus are designed as perfectly normalized to the normal form. Over to Vinayak.
Okay, so to create tables, we use SQL create table statement, which allows us to define the table structure, including the columns, data types, and constraint. For the insertion, we have used two types of insertions. First one is the direct insertion, which involves using the insert into statement to add data directly into our table. And the second one is the stored procedure insertion, which uses the pre-compiled SQL statement to insert the records into our table. This insertion is mainly used for more complex and reusable operation. And this method helps us to maintain and manage our database efficiently.
Constraints. We have multiple constraints in our database, like checking the valid first name and last name by ensuring only the alphabets are there in both the user and employee tables. So here are the two functions for the user table. Then we have added these constraints in the user table, and then we are trying to insert the invalid data in the user table. Then we have similar constraints for the employee table. And then we are adding these constraints to the employee tables and trying to add invalid data to the employee table. We have a constraint function for checking the Husky ID, like if the length is 9 and if it's valid, then only it will be added to the employee table. Then we have a computed column. So we are computing the estimated total price of each prescription by retrieving the prices of all the tests, vaccines, and medicines from their respective tables. So we can see the result from the prescription table that this is the computed column which we got from the respective prescription ID.
Next, my friend Vinayak will be explaining for the views.
Yeah. So for the first view, we have created a view that displays the number of students vaccinated with the Moderna vaccine. This view uses the vaccine ID and the prescription table, prescription data to calculate the total number of students vaccinated. This makes us easy to analyze the vaccine progress. So for the second view, to better understand the distribution and availability of the healthcare service, we also retrieve the information of the pharmacy, vaccine centers, and the test centers, and we filter this data as per the address and the state value, which allows us to focus mainly on the specific regions and optimize the resource allocations. So Siddhant will be talking about visualizations now.
So we have used Power BI to do the visualization. The first is the donut chart, which shows the numbers of center by the city. So Boston has 37.5%, Cambridge has 25%, Newton has 25%, and Lowell has 12.5% of all the centers. Next slide. So this is a bar chart which shows the types of vaccination centers available. So pharmacy has 3, vaccine centers in total are 3, and test centers are 2. Next. So this is a visualization of one of the views, which shows that there are total 4 people who have taken a particular vaccine called Moderna vaccine out of the database. Now I will talk about the future scope. So healthcare data analysis can find more trends and patterns to improve the services and develop the better treatments, and predictive analytics can be aid in identifying health risk and recommending preventive measures based on the patient's medical history and current health status. Thank you.
And we are open to any questions that anyone might have.
Okay, so could you go back to your views, and there is something called as Massachusetts centers. So
Yeah.
like, could you like explain that again? Like, because it said the centers and the uh,
Yeah. So what we are doing is, so we are thinking it from a customer perspective. If a customer is located in Massachusetts and wants to know what all pharmacies, vaccine centers, and test centers are near him, he would in an actual website he'll just filter with state. We're just doing the same. We're just filtering all these centers which state during the address table. The address table has the state value, and the address is given to each centers, and based on that we are just filtering out all the pharmacies, all the vaccine centers, and all the test centers which are situated in Massachusetts.
all right. So basically, you're filtering it out and giving it to them in a particular region. I got it. Thank you.
Yeah, correct. Yes.
Thank you.
Okay, thank you for the good work and the presentation from Team 16, and thank you for the question. Let's welcome Team 17.
Hello, everyone. Varun, could you?
Yeah, you are on now.
Yeah. Go ahead.
So our topic is payroll management system. Next. The purpose of the project is to establish a database to store the information needed to create and support employee payroll information. The user would also be able to generate payroll data depending on the month when entered to the system, along with reports that would provide details on various data segments. Next. The business issues addressed here are it is trustworthy with non-perishable employee data storage. Using automated calculation and computation, the likelihood of errors in calculation is eliminated, and also provides adherence to tax regulation. When creating the payroll data, the added advantage of the employees such as travel, food, and health allowance are also taken into consideration. This helps to decrease the amount of manual labor required to verify the accuracy of the system and the accounts. Next. So the business rules implemented are each employee has a unique employee ID in the database. There is a list of departments with each department having unique IDs. Each payroll ID must associate with the unique employee ID in the database. All employees should report to some employee other than themselves. Next, Uday will take over.
So here is our entity relationship diagram. The employee data entity is the main one, and the other entities have taken references with the attributes of the employee data. Coming to the employee address entity, all the attributes and the employee ID attribute is referenced from employee data. Similarly, the designation, leave, pay grade, everything is interlinked with the references from the employee data table. And coming to the table level check constraints, we have implemented two table level check constraints. One of them is checking the employee's age. I mean, the employee should be at least 18 years of age. We created a function to check that, and we added this constraint in the employee data table. It will give the error if the employee is under 18 years of age. Coming to the second table level check constraint, it will check whether the employee is reporting to another employee. It means the employee shouldn't report to himself. So the employee ID and the reports to ID should be different. So this function will check this condition. If the both the IDs are same, it will throw an error. And next, Nishant will continue.
Hello, everyone. So we created a procedure for calculating the total allowance, summing up these four allowance like travel allowance, food allowance, and etc. And we are creating a trigger to update the total allowance. When we update any of the values for these four values, this total allowance will be updated. And we are also calculating, we are calling a function by defining it. So in this, we are calculating gross salary. We are taking the pay grade ID and department ID, and we are calculating by an equation. Next slide, please. And the bottom one, we are getting a deduction ID. We have a few salary bracket like 50K, 70K. So less than or below, we are getting a deduction ID, which is used for tax deduction. And in this trigger, the top one, we are getting this deduction ID, and we are triggering it from the to variable table. Over to you, Varun.
So we have a few more functions that we're using in this particular database system. One of them is guest benefits IDs. So in order to get a benefit ID, we simply pass the employee ID into our function and we obtain the benefits ID. And this benefits ID can be further used for other purposes. And then finally, the other function that we have is the get net salary. So in order to get the net salary, we need to perform some calculation. So we've created a separate function for this, which takes in an employee ID, performs all the calculation, and then gives us back the net salary for it. And then finally, our entire purpose of this particular database system is to generate a payroll. So in order to generate a payroll, we've created this stored procedure, which takes in the employee ID, it takes in the month and the year, and then it fetches data from all the different tables. It uses various functions to get the net salary, gross salary, and it creates a payroll data, and it then inserts this payroll data in the payroll table. Over to you, Abhishek.
Okay, so let's talk about the column data encryption. So we've implemented the column data encryption in the password column. As we've chosen that as the data we need to encrypt. We've taken a master key certificate and a symmetric key to encrypt and decrypt the data, and we've made use of the AES 128 algorithm. Next slide, please. So we created two views for this project. One is the employee information view, and the second is the employee salary information view. The employee information view basically is a view that provides basic information regarding the employee, such as the name, birth date, and we're joining multiple tables, such as the employee data, designation, and employee address using inner joins. We're also providing additional context to the entire project by adding by adding data about the employee's role at the company, such as their joining date or the employee that they report to, etc. Next slide, please. The salary view information. So over here, we're just talking about the payroll information, the pay slip month, and etc. We're taking data from a payroll table, designation table, benefits table, and tax deduction table, as you can see. And we've also made use of a inner join using with a variable table to relate the data. Next slide, please.
Sorry to interrupt. Your time's up. Yeah, I'll just wrap it quickly.
Yeah.
So we've used Power BI and Tableau capabilities to create some visualizations and reports. So as you can see over here, one of these visualizations is the number of employees per department. We have in our system, we have various departments like you can see over here. And this visualization will give us the number of employees in each department. Also, we've created a sort of division or classification based on the salary brackets that we've created. So these are the salary brackets and number of employees in each of these salary brackets. Then we have a leave table, which has the reasons for the leaves, and we can see like which particular leave, for example, vacation supposed to be the reason that most people take the leaves for. And then finally, we have another classification based on the age group. We have created age brackets, and based on the age brackets, we are classifying the number of people in each of these age brackets. So thank you. That was a presentation. Please, if you have any other questions, please let us know.
I have one question, that how are you calculating the salaries?
Okay, so in order to calculate the salary, every employee has a certain pay grade and it belongs to a certain department. So pay grade gives us the basic salary and the department gives us this multiplier. So in order to calculate the basic gross salary, we multiply these two values. And then in order to calculate the net salary, we deduct the tax deduction, whichever bracket the tax deduction the employee falls into. And then we add the benefits ID to it. And this entire calculation then gives us the salary of that particular employee.
Okay, got it. Thank you.
Thank you. So yeah, I think that was it. Thank you for listening to us.
Great work and a presentation from team 17, and thank you for the question. Let's welcome team 18.
And can you see the screen?
Yeah, you are on.
Okay.
Yeah, we
Yes.
can. Angita, you can start.
Hello, everyone. We are Group 18 and our project topic is Property Management System. Next. So the database purpose is, if a property management system database is a crucial part that enables property management companies to efficiently store, retrieve, and manipulate and analyze their property system data. This system can utilize across a diverse range of applications from maintaining property details to amenity and leasing details. By adopting our database solutions, companies can ensure that data is stored and managed in a structured and organized manner. If you have noticed, prospective tenants looking for rental properties often have to spend a significant amount of time visiting multiple websites and filling out numerous applications form in order to contact property management companies. So with our application, all available buildings and units can be easily viewed and rental property searches process can be hassle-free and enjoyable experience. Next. So these are some of the business rules we have implemented. For example, management company can check the total parking fee for each unit. Prospective tenants could view the available units of each building. Next, Ella will take over.
As we can see, our ER diagram contains 17 entities in total, and our property management system can be used by 3 kinds of users: management company, tenant, and prospective tenant. Each kind of user could perform their own functionalities. To solve the many-to-many relationship, we created 4 associative strong entities like lease and tenant, tenant and unit, employee and building. And the most important entity is unit, which has 2 kinds of status, neither available or occupied. The status of the unit determines what entities it has relationships with. Next, Du Xuan will take over.
Hello guys. Now I'm going to talk about the database implementation. In total, we have we have 17 entities. So we implemented 17 tables for each of it. So the DDL statements to implement a few of them can be seen on the screen. Next slide, please. We have used insert into for inserting that data into tables. We have added at least 10 rows for each of them, as shown in the slide. Next slide. In total, we have implemented 3 views. The first one is to view all the occupied units and their corresponding maintenance requests. The DDL statements used to implement the view can be seen above. Below is the output, which contains all the information related to unit and the request. Next slide, please. This view is for prospective tenants to see all the available units.
they will be able to see all the available units and their building details along with the information related to each unit. Next slide, please. We have also implemented a view to record the number of payments made for the parking for each unit along with the total parking payment. Next, Akshit will continue.
Okay, so I'll start with table level check constraints based on a function. We implemented 3. First one is to check if the lease end date is after the start date. We alter the lease table by adding a constraint based on this function. As you can see, when we try to insert a row where end date is before start date, we can see that it conflicts with our check lease date constraint. Next slide, please. Our second one is to validate zip codes. This function checks if it has only 5 digits or not. If not, it raises a conflict. We altered the address table here. Next slide, please. Similarly, this constraint is used to check square footage. But we have a business rule that minimum square footage is 100. So we have implemented this. If the value is below 100, we can see a conflict like this on the screen. Next slide, please. We have also implemented 2 computed columns. First one is the function to calculate the total bill of a unit. It takes electricity bill, gas bill, and water bill as input and gives the sum of them as the output, that is total fee. You can see the computed column in the output below. Next slide, please. Similarly, we implemented another function to calculate the total parking fees paid by unit by adding all the individual payments. You can see the computed column in the view below. Next, Dave will continue.
Okay, so for the digital visualization part, our first report is from the company side. This report shows where our building located and availability. So the table on the left side is our employee contact, as you can see. And then the histogram in the below is actually the availability in the square footage. And the map on the right is where those building located. So the last picture in the right corner is actually the floor. Next slide, please. So this slide is from our prospective tenant sites. So which mainly talk about the utilities. As you can see, the more square foot we have, the higher utility we have. And also the utility bills is showing on the right side, and which give us the average and the medium price. Next slide, please. Okay, thank you. Is there any questions?
Yeah, so do you have any ideas for any future development of this particular system?
Actually, we want to improve it with more advanced reporting features like include data analysis into trends for tenant behavior and maintenance needs. Like this would help property managers and landlords to make more informed decisions about their properties.
Oh, okay. Thank you.
Yeah, thank you.
Great work and data analysis from team 18. Thank you for the question. Let's welcome team 19. Team 19, you are up next.
Okay. Can you stop sharing your screen, please? Thank you.
So yeah, we have built a pet management system. This is a management system where a user can book a services and also get products related to the pets. So let's move on forward with the business problem. So over here, the pet owner can have a one e-commerce kind of website to get a product like shelter, food, accessories, and toys related to the pet. And on top of it, it can also book in services based on all the pets we have. The goal and the objective of this database is that it would be easier for a user to have a one consolidated part for that. And on top of it, it will help business users to check which pet services and products are more famous. So let's move on with the ERD diagram. So we have highlighted the main part in the ERD, that is the user details. Based on the user details, we next have the bookings. So it's for the pet categories and it is related to the services table. And then the order details, which we can, a business user can use for the just checking which is the more order products or accessories are selling a lot. Next, we'll move on to Ramit, who's going to show us the procedure.
So in this project, we have focused on utilizing stored procedures to enhance the efficiency of our DBMS. As a result, we have successfully developed a total of 14 stored procedures designed specifically to insert data in various tables using insert into statement. Some examples of these tables include user details, which contains essential user information, food table, which encompasses a wide range of food items, and many other tables. And when it comes to executing a stored procedure, it's quite straightforward. We start by using the execute command. This is followed by stating the specific procedure name that we wish to run. To provide the required input, we subsequently list all the attribute values in the appropriate order, ensuring seamless execution of the stored procedure. Now my teammate Hitesh will talk about computed columns and constraints.
Yeah, so about computed columns. So firstly, on the left, we can see that we have inserted all the details, like for food, say for shelter, we have inserted the shelter ID and the quantity, so the shelter quantity. Similarly for food and accessories. Then for computed column, on the right, you can see we are calculating the total amount. So here we are calling the food ID, say for food, we are calling the food ID and the food quantity. Similarly for shelter, accessories and toys, and we are adding that up and getting the total amount. Moving on to constraints. So we have put constraints on all the tables for foreign key and on delete cascade. In this, we are highlighting just the major ones, that is password, email ID, and phone number. For password, as you can see on the left, we are accepting uppercase and lowercase letters. We are accepting numeric values from 0 to 9, and we are also accepting special characters. For email, we are looking if there's @ present, that is one of the validation. And then we are accepting uppercase and lowercase letter in that as well, and also underscore. Okay, next, I would like you to continue.
So to impose certain business rules, we have used multiple triggers. So the first one is that we'll allow booking for the users which are only active. So you can see the trigger here that inactive users cannot have the booking. Then we have another trigger to stop the user from booking at the same time. So one user can have only one service booked at a time. And then we have one trigger to manage the inventory, that is how many total products are available in the stocks right now. Then we have created the views as well. So you can see that this first one is to display total sales by city. You can see that for each city, total sales amount is displayed. Then another one is to display the most sold products. So according to each product type, we are displaying that how much total quantity is been sold. So this is the code for each the views which we have created. Then there is one more view to display the most in demand toys for each pet. So here you can see that for example, for the dogs, the tennis balls are most in demand and their quantity, we can see that here. Then we are also displaying the most used services by pet type. So you can see that for each pet type, which services is in most demand and how many users have been using it. And this is the code for the views. Now I will continue with the visualization.
So we used Power BI to calculate or to create visualizations for our views. So this is a representation of our most sold products. As you can see, it's broken down by each product and the amount sold, but also shows on the right that food was the highest selling category and shelter was the lowest. This shows our most booked services, and the cat grooming and hamster exercise were tied for first, but that could change in the future. The most in-demand toys, this is per pet. So the legend shows each pet and then the colors coordinate to each pet and the highest selling toy for each one. And then finally, our total sales by city, showing that Houston has the most and Miami has the least. Obviously, this will also change and can be represented for certain times, but this is the total. And that's our presentation. Thank you for listening. Any questions?
Hello, Group 19. So I have one question for you. Can we book multiple services for all kind of pets, or is it just for few pets?
Yes, right now we are providing like almost 10 plus pets. So you can book services for all kind of pets, and it's not limited to certain pets. And we can add more pets if required. And you can book multiple services at the same time for different pets.
Okay, thank you.
Any other question for Team 19 or comment? Okay, great work and presentation from Team 19, and thank you for the question. Last but not the least, let's welcome Team 20. Team 20, you're up next.
Hi, this is Priyanka here. The topic that we are presenting today is grocery database management system. First of all, we'll look at the purpose and the problems addressed. So the purpose of the database we have is we are trying to manage the customer's data, analyze the data to make informed business decisions. We're also trying to identify trends, customer preferences, and optimize store policies and processes to increase the sales and the customer satisfaction. Next, the business problems that we are trying to address here is analyze the data by the region and gender in order to understand various features. We are trying to answer questions such as which branch has the best performance and reward program, does customer feedback affect membership? Next. We are also trying to address problems such as identify the trends in the patterns in customer shopping path and association in their orders, keep a track of different product details, eliminate the product related issues, and take informed decisions on discount and sales. Now Kinjal will take over.
Okay, so now we'll come to the entity relation of our database. The schema represents a database for the online store that has information about various entities. The customer table stores information about customers with their personal details and login credentials. Password column in the customer entity is encrypted. Customer can place order, therefore it's connected to the order with a non-identifying relationship, and the customer will give rating to each product. Coming to the store entity, it can place order to inventory. The customer order table is related to the customer and store tables with store information about the customer orders. The products table stores information about the products. And lastly, there's the payment table, which is related to the customer order table. Therefore, the order ID is mentioned as the foreign key.
Hey, hello guys, Suraj here. So the next part which I'm going to explain is the database implementation. So in the slide, what you can see is the create statements which we have used to implement our database. We have in the bottom right corner, you can also see that we have encrypted the customer password column. So coming to the next part, we have use the insert statements to enter the random data into our database. The main highlight is that we have entered 22 categories of products and 135 different subcategories also. So the next part is the triggers, roles, and functions. So the one of the important trigger is the new order trigger. So whenever a customer places an order, this trigger updates three tables, which is the payment table, order details table. Order details has all the details related to different products which the customer has placed into its cart, and the store and also the quantity of the store. So that's what this trigger does. So the next trigger is the calculate total price trigger. So whenever the store places an order towards the inventory, this trigger calculates the total price of all the products which the store has placed an order for. And the next is the store order trigger. So whenever the inventory manager, so there's a role called as inventory manager. So whenever an inventory manager tries to approve the store order, so if the product is available in the inventory, it approves the order or automatically rejects the order. So yeah, so the next part is the roles. We have also created different 5 roles in our database, and every role has been given a different level of access to different tables. On the right hand side, you can see the grant statements, which gives different level of privileges to every role. Yeah. So the next part is the views. So here we have created different views, and each views has a different level of access for the different level of roles, which you have seen in the previous screen. Okay, and then comes the functions part. So we have created different functions. So you can see there's the computed function called as calculate discounted price. So whenever any store wants to go on sale or put an extra discount, they can trigger this function and it will update the new discounted price for all the products in their store. And also in our database, there are total 14 views, 5 triggers, and 3 computed functions. And all these the important ones.
So
Yeah.
next
So
will
next
be
will be
taken care by the
Pushka. Pushka.
Yes, thank you, Suraj. So next would be data visualization. So the next slide, please. First is the donut chart, as you can see, where sum of order count is displayed with respect to the days of the week. This chart helps us to analyze that weekends are higher, weekends had higher sales. The second chart symbolizes the products which are low in price have high sales because we implemented a trigger with card minimum of $5. The third chart is a normal bar plot, which clearly shows the products with with highest discounts are sold more. The fourth is this chart helps us to understand concepts of cross selling. The fifth chart the fifth chart explains loyalty membership. So we have introduced this loyalty membership where if the customer goes for a loyalty membership, he purchase more as there is a extra 5% off. And the fifth is the heat map. This is with respect to the stores which we have in Boston. So to summarize, data visualization gave us more detailed view to our project. We realized that data visualization helps in taking better decisions, easier trend analysis and data exploration, more accurate customer sentimental analysis. So thank you guys. If you have any question, we are open to the questions.
Yeah, hi. So I wanted to ask you, you guys,
Hello.
like, how
Yeah.
did you implement
The
inventory
way we
management role?
implemented was first we executed.
Hello.
Hello. Could you repeat the question?
Yeah, I was asking, how did you implement inventory management role?
Inventory management, sorry, didn't get you. Inventory management role.
Yeah.
So, for the inventory management role, we executed. We granted permissions. We created the role for inventory manager, and then we created a login ID and password, and then we set a user for it, and then we granted multiple permissions, CRUD permissions to the inventory manager. That's how we did the role part of inventory manager.
Oh, okay, got
So,
it. Thank you so much.
Yeah.
Great work and the presentation from Team 20. Great data analysis. And thank you for the question. This is the end of our presentation. And I'm impressed with your accomplishments in DAMG 6210. Kudos to everyone.